All right, now we're going to look at those linear equations and we are going to solve systems of equations. So more than one equation, we're going to find the answer, the coordinate pair that satisfies more than one equation. So we're talking about systems of equations. There's multiple equations, and we're going to look for a solution, right? So you got two or more linear equations. That's a system of equations, and that solution is going to be an ordered pair that satisfies each equation in the system. So if it's the solution for both, it will make both of them true. So, for example, here are two systems. Here are two equations. There's one system. There's two equations. Now, given this ordered pair, decide if it makes both of these true, which means you're just going to plug in 5 for x and 2 for y and see if it is true, which goes back to when we looked at identities and true equations previously. So here we go. Substitute it in there. 0 does indeed equal 0, right? 2/5 times 5 equals 2. 2 minus 2 is 0. 0 does indeed equal 0. Same thing here. Substitute in your 5 for x, your 2 for y. 3 times 5 is 15. Minus 2 equals 13. So that is true. So this pair is a solution for this system. It's a solution for both of these equations, which means this point 5, 2 is on the line of the graph of both of these equations. If you're doing this and you figure out it doesn't satisfy one of them, then obviously it's not going to satisfy both of them. All right, same thing here. We're going to plug in our ordered pair for our x and our y, right? Our -2 is our x value. Our 2 is our y value. We're just going to plug those in and solve to see if it is true for both equations. So plug in your -2 for your x, plug in your +2 for your y. 3 times 2 is 6. -2 plus 6 is +4, and +4 does indeed equal +4. Over here, doing the same thing. Plugging in -2 for your x. A -2 is a +2. You've subbed in your 2 for your y. A +2 plus +2 equals 4. And 4 does not equal 2, which means this coordinate pair is not a solution for this equation. So it does not satisfy this system. All right, your turn. Pause the video, substitute in 1 for your x values and 3 for your y values, and then simplify to see if this coordinate pair is a solution for this system of equations. And here we go. Hopefully this is exactly what you have on your paper. And you see that it does indeed satisfy both of these equations. Same thing. Same thing here. Pause the video and solve. All right, so hopefully you substituted in 2 for your x values and -1 for your y values, and then simplified to see if these are indeed accurate answers. And then hopefully, once again, this is exactly what you have on your paper. And you realize that this is not a solution. All solutions of a linear equation are on its graph, which makes sense because the line is that linear equation. So to find a solution of a system of linear equations, you can, basically you're looking for a point of intersection. So when you have a system of equations that is in point-slope form, which is what we have here, point-slope form, then you can graph both of those equations and determine if they intersect. And if they do intersect, then you can determine what that point is, and we'll straight up give you, that that one is a solution for both equations. So if we graph them, which we know how to graph them, you see that this line, the y-intercept is -1, and then you got rise over run, plot that line. Same thing here. Your y-intercept is +5, and rise over run is -1 over +1. Bada bing, bada boom, bada bing, bada boom. You see the point of intersection of these graphs is the coordinate pair 2, 3, and that is the solution that satisfies this system of equations, this set of equations, right? Sometimes it's tough to figure out if it's, if it's not directly on a point. Sometimes it can be hard. And if you have that problem, you can just substitute the point that you think it is into your equations and see if it does indeed satisfy both equations. So we're going to graph these equations, right? Y equals x and y equals -2x plus 3. Once again, you see this has no y-intercept, right? So in the x as a slope means 1 over 1. So let's graph these equations. We're going to graph this system, right? No y-intercept means the y-intercept is 0, 0, right? And so this line is rise over run, 1 over 1, right? And then this equation, the y-intercept is -3, and you have a -2 over 1, right? Or you can do +2 over -1 because it works both ways. So you go rise 2 over 1 because you're trying to get in here, and you see that this point of intersection, you think it's -1, -1, but you can't quite be sure. So you can substitute it into the systems to see if it works. -1 for x and -1 for y. -1 does indeed equal -1. Substitute it into your other equation for x and y and simplify your equation. And you see that absolutely -1, -1 is the point that satisfies both of these equations. So it solves the system. All right, try this on your own. Go ahead and pause the video, graph both of these lines on your graph paper, and find the point of intersection, if there is one, and determine that that is your solution for these equations. All right, so first, you probably noticed that you had to put this equation into slope-intercept form, right? So we're going to move this 1/3 x away from the y because we're solving for y. And so we get this equation equals 1 equals -1/3 x minus 1. Hopefully you got that first. And then we're going to graph, in this case, you can graph it with a graphing calculator if you have one. If not, graph it on your graph paper, right? And there's your two lines. And this point of intersection is 3.75 and -2.25, which you probably could not determine, right? You couldn't determine that on your own. So you had to substitute those numbers in to solve. And you figured out that that was accurate. 15 over 4 and -9 over 4. Okay, we're going to do the same thing here. Graph the system, right? So pause the video, graph the system, find the answer. All right. So these are both already in slope-intercept form. You see that for this equation, our y-intercept is -1, and our slope is a -2 over 1, or a 2 over -1. So we'll go up 2 and over 1 to the left, up 2 and over 1 to the left, drawing our line. Here we have y equals x plus 5, so our y-intercept is positive 5, and our slope is either positive 1 over positive 1 or negative 1 over negative 1. So you can go down and to the left, down and to the left, and then draw in this line, and you see that these two graphs intersect at negative 2, positive 3, and that is your answer. You're going to check it by plugging it in as before. Plug in your negative 2 for your x values and positive 3 for your y values and see if it works. It does indeed. This one, similar, right? We have to rewrite this one in slope-intercept form. So we're going to have to remove our 2x from this side. So we're going to get y equals negative 2x plus 4, right? If you have a graphing calculator, you can graph it. If you don't, you can graph it on your own, and you will have found that the intersecting point is 3, negative 2. So that is your solution to the system. Plug it in to both equations to determine if it does indeed satisfy both equations. It does indeed. So that is your answer. All right, now we're going to do a word problem that is going to be 2 linear equations. We did this before when we made equations equal to each other in order to solve them and figure out what the variable was. In this case, we're going to have 2 linear equations, and we are going to solve them for a single point that satisfies them both. All right, Ren and Jenny are reading the same book. Ren is on page 14 and reads 2 pages every night. Jenny is on page 6 and reads 3 pages every night. After how many nights will they have read the same number of pages? And then how many pages will that be? So, what information do we have that's important? Ren's on page 14, reading 2 pages a night. Jenny's on page 6, reading 3 pages a night. Let's figure out what we got. Total pages is the number of pages read every night plus what you've already read. Ren, y is the total pages, right? Number read 2 per night, so 2x plus Ren's already read 14. Jenny reads 3 pages a night, so 3x, and is already on page 6. So we're going to graph those equations, right? So graph the equations. And once you graph those equations, you will see the intersection point at 8, 30. So the number of pages read will be the same after 8 nights, because 2x and 3x mean x is the number of nights, and then y is what you get. That's going to be the total pages. So after 8 nights, both people will have read 30 pages, right? There's your graph, right? And then we can see if it fits. Plug it in. It does. And indeed, it does. All right, we're going to do one more of these, and then we will check out solving systems in a different way. So Video Club A charges $10 for membership and then $3 per movie rental. Yes, that's right. Once upon a time, there were video clubs, there were video stores that you actually had to go to in order to rent movies. Oh my goodness. Unfortunate. Although Redbox is still a thing, if people still go to Redbox, I'm not sure. I very rarely leave my house. Anyway, Video Club A charges $10 for membership and then $3 per movie. Video Club B charges $15 per membership and $2 per movie. So I want you to know, this is proven to you that algebra does actually help you in real life. It helps you figure out which one is going to be best for you in the long run, right? So let's figure out how we want to write this. So how many movie rentals is going to make it the same cost for both clubs. So this will help us. All right, so we need to know what's up, right? So Club A charges you $3. Club B charges you $2. The membership at Club A is $10. The membership at Club B is $15. So hopefully you're looking at this and realizing that per rental, 3, so that'd be 3x, right? Because x is how many rentals you have. Club B, $2 per rental, that's 2x. So this is your slope. And then Club A, your membership is $10. So that's where you start. That's going to be your y-intercept. Club B, $15. That's where you start. That's going to be your y-intercept. So we're going to write it out. We're going to figure it out. Total cost is y. Price per rental, 3x plus membership fee, $10. Club B, $2 per rental, 2x plus 15. That's your original membership fee. So if you graph those both out, right, your point of intersection is 5, 25. That's where they both intersect. Once again, looking at your lines, 3x plus 10. 10 is your y-intercept. And then 1, 2, 3, over 1, up 3, over 1, up 3, over 1, up 3, over 1. This graph is shrunken. So it'd be up 3 over 1, up 3 over 1, up 3 over 1, right? So we shrunk this down so we could see them. Hopefully you've got this on your whole graph paper. It's huge, just taking up so much space. So at 5 movie rentals, the cost will be equal, and that cost will be $25. We figure that out by plugging it in. All right, plug in your 5, checking it. So at 5 movie rentals, the cost is $25, and it's equal. All right, that's all for that. Now we're going to check out solving systems of equations by substitution. Solve linear equations in 2 variables by substitution. Same thing, y equals mx plus b, we're solving by substitution. So we're solving basically by using algebra rather than graphing to figure out what the answer is. We're still finding one point that satisfies both problems. Sometimes it's just tough to see or tough to graph or whatever. So solving systems of equations by substitution. Step 1, solve for one variable and at least one equation if you have to. Sometimes you don't have to, they're already solved. One of them, you only have to have one that is solved for one variable. And by saying solving for one variable, it means you have that one variable by itself on one side of the equal sign. And then you take that and you plug that whole, what you get, you plug that into the other equation, and then you solve it. So basically, this is all algebra. Solve that to get one variable, and then plug that variable, that solution into the equation to get the other variable. I know it sounds like a lot, but it is algebra. So solve the system by substitution. Y is equal to 3x. Y is equal to x minus 2. So if y is equal to 3x, we can plug in all of this, 3x, for this y, and then solve it algebraically, right? Substitute 3x. So just to be clear, y is equal to 3x, and y is equal to x minus 2. So if y is equal to 3x, you take everything here that y is equal to, and you plug it in for y in your second equation. And so we end up with 3x is equal to x minus 2. And then this is the same skill that we worked on for solving equations with variables on both sides. So we are going to get rid of this x over here. 3x minus x is 2x. 2x is equal to negative 2. Now we want to get x by itself. So we're going to divide both sides by 2, right? 2 divided by 2 is equal to 1. You get your x by itself, which means x is equal to negative 1. So now we know one part of our ordered pair, x negative 1. Now, go back to your original equation, one of them, doesn't matter which one, and substitute in what we just found out. -1 is x, plug that in. So 3 times -1 equals -3. And now we have our y coordinate. So x was -1, we solved for that, and then we plugged x in and figured out that y is -3. So the ordered pair -1, -3 is the solution to this system of equations. And we plug it, we can substitute it in for both equations and solve to determine that that is true. All right, we are going to do the same thing. We're going to solve this system by substitution, algebraically. Solving it algebraically. Once again, your first step is to make sure you solve at least one equation for one single variable. This is already done for us. We know that y equals x plus 1. So now we're going to take everything that y is equal to, x plus 1, we're going to take everything that y is equal to, and we're going to plug it into this equation where we have y written. Plug that in. See, 4x plus x plus 1 equals 6. Now we're just solving, so we're going to collect our terms, right? 4x plus x is 5x plus 1 equals 6, right? And now it's just a two-step equation, which we know how to do. Subtract 1 from both sides. 5x is equal to 5. Got to get the x by itself, so we're going to divide by 5. And then x is equal to 1. Now we know our x value. So we're going to go back to one of our original equations, it doesn't matter which one, and we're going to plug in 1 for x. 1 plus 1 is 2. So now we know the ordered pair is 1, 2. That is the solution for this system. And we can substitute it back in to solve. All right, here we go. This one is a little more difficult, but not much. We are going to solve for one of our variables. It's easiest to solve for x, right? So we are moving this whole term, this whole variable term, 2 times y, we're moving the whole thing over here. We are getting rid of it here. So we're going to subtract 2y from both sides. So x is equal to -2y minus 1. Now that we know what x is, we're going to substitute that back into the equation. Substitute back into the second equation, right? We can't substitute it into this equation. We have to substitute it into the other equation. That whole thing, x is equal to -2y minus 1. So this whole thing, -2 minus 1, we plug it in for x, and then we solve. Simplify. Collect your terms. -2y minus y is -3y. Minus 1 is equal to 5. This is just a two-step equation now. We know how to solve these. Add 1 to both sides. We get -3y is equal to 6. And then we want to get y by itself, so we have to divide by 3. We have to divide both sides by 3. And we get y is equal to -2. Now we know what y is. Go back to one of our original equations, and we plug in what we know y is into that equation and solve for x. X minus -2, as written here, right? Minus a negative is a positive. So x plus 2 is equal to 5. Subtract 2 from both sides, and we get x is equal to 3. So we now know what our y is and what our x is. So our pair is 3, -2. All right, do this one on your own, and then, so pause the video, do this one on your own, and then come back. All right, this time we're lucky. It is already solved for y. So we're just going to plug it in. So we know that y is equal to x plus 3. We know that y is equal to 2x plus 5. So we can take all of this and plug it in here. So y is equal to 2x plus 5 is equal to x plus 3. And then now we're just solving an equation with variables on both sides, which we know how to do. Go through our steps. Subtract x from both sides. And you will get x plus 5 equals 3. And then subtract negative 5 from both sides, or subtract 5 from both sides, and you'll end up with x is equal to negative 2. Now that we know what x is equal to, plug it into one of our equations. Negative 2 plus 3 equals positive 1. The solution is negative 2 comma 1. Solve this system by substitution. Pause the video and then come back for the answer. All right. So the first equation is already solved for x. So we're going to take everything that x is equal to, and we're going to plug it in here where our x is in our other equation. 2y minus 4 plus 8 equals 16. We're going to collect our terms. 2y plus 8y is 10y. Minus 4 stays the same, equals 16. I'm going to add 4 to both sides. Gives us 10y is equal to 20. And then we're going to divide both sides by 10. And y is equal to 2. So we know what y is. Take an equation, substitute 2 where you see y, and then solve it. X plus 8 times 2 is equal to 16. Subtract 16 from both sides. X is equal to 0. And then we now know both our x and our y coordinates. And that is that. All right. So we have to solve one of these for x. Subtract y from both sides. So you get x is equal to negative y minus 7. Now we're going to plug that into our first equation. Plug it in. And you see here now, right, we're going to have to distribute our 2. Right, we had a coefficient here. So now we have to distribute our 2 because where we had our x, we put negative y minus 7. So now we have to distribute. Negative 2y minus 14 plus y equals negative 4, right? This is just a multi-step equation now. No big deal, just a multi-step equation. And so we are going to just collect our terms and solve. So we're going to collect our terms. Negative 2y plus y gives us negative y. Minus 14 is equal to negative 4. We're going to add 14 to each side. Gives us negative y equals 10. And then we have to basically divide by negative 1 to get rid of our negative sign. 10 divided by negative 1 is negative 10. Now we know the y coordinate. Put in negative 10 where we see y. X plus negative 10 is the same as x minus 10 equals negative 7. Add 10 to both sides. We get x equals 3. And we now have our solution. We have our ordered pair. All right, we're going to solve this one. Go ahead and solve this one on your own and then come back. And then we will do a word problem after this one. All right, so first thing we have to do is solve one of these equations for a single variable. Easiest thing to do is going to be to solve for y because that is the only variable that's already close to by itself. So we're going to subtract 6x from both sides. So we get y is equal to negative 6x plus 11. Then we're going to go back to our second equation, right? substitute everything that we have here for y into the second equation. So 3x plus 2y, so 2 times everything we found out y is equal to, equals -5. And then we're going to solve this equation. And yes, it is a multiple step equation, but we know how to do all this stuff. So it's just a matter of doing it the right way. So you have to distribute our 2. 3x plus 2 times -6x plus 2 times 11 is equal to -5. Right? So we get 3x minus 12x plus 22 is equal to -5. Continue to simplify, collect our like terms. 3x minus 12x is 9x. -9x plus 25 equals -5. Subtract 22 from both sides. So we get -9x equals -27. Divide both sides by -9. -27 divided by -9 equals +3. So we now know that x is equal to 3. Go back and substitute x into one of our equations, right? So we substitute our 3 in here. Simplify. Y plus 18 equals 11. Subtract 18 from each side, and we get y is equal to -7. We now know our x and our y values. So that one is done. So now we are going to solve this word problem. Jen is deciding between 2 cell phone plans, right? Once again, first plan has a $50 sign-up fee and costs $20 per month. The second plan has a $30 sign-up fee and costs $25 per month. After how many months will the total cost be the same? And what will that cost be? And then it continues to ask, if Jenna has to sign a 1-year contract, which plan will be cheaper? So we got a lot to do here, but first thing we need to do is write our equations and solve the system. So total paid, T, you could just as easily have used Y. You get your $50 sign-up fee plus $20 per month, or a $30 sign-up fee plus $25 per month. Both equations are solved for T, right? So we'll take everything that we know T is equal to and substitute it into the other problem. And we see we now have an equation with variables on both sides. And we will solve it in that manner. Subtract 20m from both sides. Leaves you with 50 equals 30 plus 5m. Now we're going to subtract 30 from both sides to get this 5m by itself. Right? Gives us 20 is equal to 5m. Divide both sides by 5 and gives us m is equal to 4. So after 4 months, they'll be the same. Take one of your original equations and substitute that in. Since we know what m is, 25 times 4 is 100 plus 30. So T is equal to $130. So after 4 months, the cost will be the same, and that will be $130. Now, it asks if you have to sign a 1-year contract, which plan will be cheaper. And so 1 year, remember, you're doing this in months. So 1 year is 12 months. So substitute in 12 for your months and solve. You get $290 for the first plan and $330 for the second plan. So once again, algebra has shown you that the first plan is better. And that is solving systems of equations by substitution, or solving systems of equations via algebra.